Done. Recording has been started. Matt, do you want to talk or do you want me to talk?
Why don't you talk? I just got up and came out of another meeting, getting ready for on-call. I haven't mentally shifted yet.
So let me get up that. So right before Bob left, he did a bunch of planning and created a lovely epic that had a bunch of linked issues and a suggested method for how to go forward. And then he went on vacation, and Matt and I looked at the issue and said, yeah, we're not going to do it in the way that Bob said, and did our own thing, which is kind of true. So the issue, the epic question here, I'll put it in the chat in case anyone doesn't have it up. Essentially, the decision that Matt and I made was Bob suggested creating some metrics to start with so that we could appropriately size this. And Matt and I said, we can probably just come up with a number and start building things. So we did. We should probably go back in time and come up with those metrics, though. I think they would be useful, but we didn't do it first. So the issue that Matt and I have been working on is spin up a new Redis cluster for repository cache data 1821. And that has a lot of linked sides on that. There's a lot of discussion there that I will recap very quickly, which is there was some discussion around whether or not we should use whether or not we should use generic node pools for this or create individual node pools for each Redis instance. The end decision was that we're going to keep moving forward with individual node pools for each Redis cluster, but that we would go back and look at whether or not this made sense to do in a different way when we weren't quite so pressed for time. A couple of people from the reliability team had some probably valid, but maybe not valid enough conversations around ease of management and how many Redises we were going to have and things of that nature that likely need some experiments to see what the trade-offs are between that and Redis's issue around latency and how it will handle having potentially other things sharing the same set of machines. So after we did that, and then Matt came up with a sizing, we built out a cluster in Thursday, sometime last week on a day that I don't remember what day it was, but it was definitely last week.
Yeah.
Which worked on the first try, mostly without issue, which candidly surprised me. So pretty impressed by that.
And that's using the work that Igor and have been doing also.
Yeah. And by using, I mean, it was literally a copy paste and a change registry to repository. So, I mean, it's directly theirs. We did discover when we built that out that there are a couple of tweaks that we need to override for this instance, which Matt looked at some of the details around and we haven't actually changed yet, but will. So specifically things around, what did I say it was? Things around like setting max memory in this and how many CPUs it could use and what CPU or what memory amount we were going to assign to the node pools. I think a couple of other things, but the MRs are in place to do the exact same thing in staging and production. They will need to be updated once we update the things for pre. I just did it while I remembered what I was doing. So those are ready to go. So next, I mean, is that a reasonable recap, Matt?
Fantastic, absolutely fantastic. The only thing I want to add is, so we have an existing cluster. We know that we want to make some tuning adjustments to it. We've figured out how to effectively these are changing the pod resource limits and some Redis config changes. like setting an eviction policy other than no eviction. We found out how the Helm chart exposes that and how to control that through the Tonka recipe. So that's our literal next step for adjusting the cluster that we've already built. We also rationalized the sizing decisions that we made on the premise that we think that reasonably this should be large enough, and it shouldn't be just massively too large. And if we're wrong, it's not particularly expensive to resize, which is why Stephanie was saying that we still do want to get the metrics, but we figured it didn't need to be a blocker for getting the cluster built.
No, and since we're rolling out incrementally.
Yes.
Then, yeah, we can.
Yes.
We'll see when we hit the ceiling. Before
Exactly.
We hit the ceiling.
Exactly. So there's one other thing I want to make sure to mention. Two other things I wanted to add. One is we realized that there's a readiness review being drafted for the work that Igor and Alejandro are spearheading. We haven't. Stephanie and I were talking about whether or not we need to A, do our own readiness review, or B, add on to that readiness review and treat it as a blocker for our work. We haven't settled on that yet. It kind of depends. I mean, we can kind of justify it either way. But the other piece I want to add is this work that we're doing, the Redis repository-cache, or specifically reducing the memory storage demand on Redis cache, is more urgent than even I realized.
Jakob informed me slightly.
Oh, so you've already heard. Okay, yeah. So we already knew what how these eviction spikes impact latency, but what I hadn't thought of is Sentinel is real close to that timeout, and we crossed that threshold a few times. I think we had Sentinel trigger failovers enough times that Sentinel said, "Whoa, I'm invoking my backoff logic." If that says where we're at. Yeah, so there's a few things we can do about that. One of them is, I don't think I made an issue for this yet. Sentinel's runtime state is different than what we configure in Chef. Chef is configured to give it a 60 seconds of patience for its heartbeats, and the runtime state gives it 10 seconds. I don't know which of those was done more recent. Like, I don't know which one we intend to keep. I think 15 seconds would be a reasonable thing to make as a runtime adjustment now, and maybe make Chef conform to that. 60
Isn't
seconds.
This the number isn't this the number we adjusted in that incident where Igor made a Sentinel change to stop failovers? Is that the heartbeat time, or was that some other number?
Yeah, it's down after milliseconds, I believe. It's spelled something like that. And yes, it is. Its sole purpose is to adjust how long Sentinel will wait for its before declaring a failure and initiating an election and a failover event.
Because we crank that number up by to something so high that it just wouldn't happen at all.
Yeah, that's probably the 60 seconds that I see in Chef, but that's not actually applied. The runtime state is set to 10 seconds. So I don't know if that's because someone came back and changed it again without updating Chef, or perhaps without merging an MR into Chef. That's where I need to do some legwork. I found the discrepancy and I haven't done anything to change it yet.
Because there was an MR in the middle of that one incident 2 weeks ago, just before I went on leave. Yeah. To stop the failovers, and then we had the other. Well, there was this other problem of not just the failovers, but also the fact that replication wasn't finishing.
Right. We dealt with that by increasing the buffer size.
Yeah.
Yeah. So I guess there's a lot to talk about with regard to the failover behavior, but running out of space in the buffer that we were triggering that depending on time of day. So unfortunately, those failover events were happening pretty close to within a couple hours of the daily peak, and so the buffer was filling up just slightly before finishing the setup for the replicas. I think we doubled its size from 4 gigs to 8 gigabytes. So we should be out of danger for that. That was one of 2 reasons why we were stuck in this feedback loop of repeatedly attempting to do failovers. The other reason is this timeout being a little bit too short.
Which timeout?
The down after
Sentinel
milliseconds. Yeah,
no, but we changed that before, and it kept. So even after we increased that timeout, it kept going in a.
That's what I'm saying.
Replication loop.
Yeah, exactly. So it kept going in the restarting replication because the buffer would fill up before it could finish reinitializing the fresh replicas. But apart from that, it entered that cycle because the timeout wasn't patient enough. And that happened again. What happened again was that we reached that threshold and
we had another failover for no good reason.
Yes, exactly.
We don't want latency to cause a failover.
Yeah, at least not
because it's not going to get any better after the failover. So
yeah,
you should failover because the machine is down or something.
Yeah, and waiting 60 seconds to trigger a failover when the machine is down feels like too much. But
yeah, that's also not right.
Yeah, exactly. So that's why we were thinking about maybe nudging it up just a little bit, especially since we know that we're going to reduce the size of this instance.
But we don't know by how much.
Right, exactly. So I figure adding 50% seems like it's reasonable. So I was kind of leaning towards 15 seconds, but I haven't made any changes yet. So this is yeah, that's kind of where we're at.
It's probably worth also mentioning, which I had also forgotten, that all of the infradev issues that Bob put in before he left have had progress.
Yeah.
One of them has been completed, but it was the one to reduce the TTLs, so it had the least impact. I looked a couple of times to see if there was any visible impact, but there wasn't really. Most of the other ones, as of Friday, had MRs associated or things of that nature, but weren't at a point that we could look at. So work is happening on that side. It just hasn't done anything yet. And we don't know how much that's going to save us either. So there's a lot of question marks on all of this.
So thanks for letting me into this meeting, which I kind of invited myself to.
Technically, I invited you. So.
Yes,
welcome.
Yeah. But
and welcome back, by the way.
Yeah, thanks. I've been involved with this off and on, but not as much as all of you have been recently. So I have some context, and I have some. I guess there's a couple. I have a take a step back question.
Yeah, please go for it.
Because apart from, I mean, we've been having issues with Redis-cache all the time. We went through this thing at some point with, I mean, we've been blaming clients connecting and driving memory up, and then we realized that the way Redis does eviction is not great because
I mean, that was also correct. Yeah, the client connection thing was real too.
Yeah, exactly. So that was real. And then there's the problem that in order to enforce LRU, it just basically stopped the world garbage collection, which is terrible. And my armchair question is now, is this telling us that Redis just sucks for this? And I have a hand wavy justification for this, because Redis started out as a distributed in-memory store, so that application servers can have in-memory data structures like linked lists and hash maps, and have shared access to it. And using Redis as the cache was bolted on later. And because these things that are going wrong, I find kind of lame. And like, if you're a cache, come on, you have to be able to evict stuff quickly. If you're an LRU cache, it's kind of part of the job. And so this crazy thing I just threw out there of saying, should we be using memcached is based on the fact that as far as I understand, memcached is meant to be an LRU cache, and is from its early start supposed to be a cache. And it's a boring choice. It's probably the most boring open or Varnish, I suppose, but Varnish is usually used as a proxy. So if you want the key value store, a memory backed key value store, then memcached is sort of a boring choice. And Bob made the interesting observation that a lot of our work goes through a Rails cache, which is backend agnostic. So can we expect some of these problems to go away if we would not be using Redis in the first place?
So I think that's an interesting topic to explore. So I'm gonna give some off-the-cuff responses. My first response is my gut reaction is I would want to assess the bottlenecks, and so anytime we talk about technology change, even swapping in one boring technology for another boring technology, I always want to understand what the trade-offs are and what constraints we have on the problem space, and so that's not necessarily a large amount of work, but it's some time for reflection and assessment of what are the constraints on our problem space, and what are the trade-offs that we'd be making, and probably some rudimentary synthetic testing to assert those cases. We're not directly using memcached in any context.
It's a completely nuts idea because we're not deploying it at scale anywhere.
Thanos use that?
Say that one more time.
Don't we use memcached and Thanos?
For Thanos, yeah,
Yes.
that's exactly what I was about to mention. It's not part of the GitLab application suite. It is part of Thanos. We do an awful job of managing it there, in the sense that we don't, and we need to. So yes, it's there, and that doesn't mean that we have that we've built up the expertise to
No, we haven't. No.
Yeah. So I just want to be explicit about that. We suck at managing memcached right now.
Yeah.
We can level up, but we're not there yet. I do think it's an interesting idea. Oh, go ahead, Pop.
The work that we're doing now actually will make it less. Will make a new technology like memcached more accessible, because we can decide on a smaller piece. Like now, what Jakob was not suggesting but thinking out loud was, let's just use memcached for rails.cache. But now we're slicing off a piece of rails.cache and moving it somewhere else, which means we will have two rails.cache things that we can try this on. We can even, since we've done this migration, try another slice that's even smaller. And I'm currently I've seen way too many view cache kind of things that use rails.cache that we might be able to,
So
and I understand that this project has some urgency to it.
It does,
and that makes it this suggestion inappropriate for this project. But
you're thinking medium term, long term.
But I think in the larger, we've been, ever since I've been on scalability, like shortly after I joined, we started looking at Redis, and it's been clear that Redis cache has been a mess. And even before that, before I joined, I know that Matt and Igor spent a lot of time looking at Redis cache before that. So it's this ongoing, I know it's been a problem child for a long time. And with all the digging we've been doing into how Redis works internally, I have some doubts about whether it's just a good idea at all to use it for a cache workload.
So I do want to mention that we've been saying for a few years that we need to that we need a more scalable solution, and Redis cluster has been kind of the go-to, the leading candidate.
Yeah.
I'm still putting my eggs in that basket. But I'm certainly not opposed to exploring other options, and I think memcached is a great other option to explore.
That seems like the right time to explore it too, when we're like, look at Redis cluster, look at memcached, look at whatever else we decide might, I mean, probably not varnish, but I don't know, maybe there's something cool and new out there, which probably would suck in an entirely different way. But the other piece on that I think is also still worthwhile, which I brought up before, is caching speeds up what we're doing. But I still don't think we have really good observability on what we're caching and why, and is it actually useful? So I think that needs to be part of any kind of what we're doing. It's like what we're doing in the future is this caching worthwhile? Are we just adding another hop to something that might theoretically be faster? Like if you spend all your time caching a single page that no one ever looks at again, caching doesn't improve anything.
Yeah, that's very much. And when I was looking into these things, like we're often caching stuff for one user. And then, yeah, so I've been working on some things with stage groups to like they then instrument their own thing. Like I said, this key uses a lot of memory. Could you look into that? And then I mentioned add maybe hit rate metrics, so we can play with TTLs and so on, with like making informed decisions on that. What we don't have in for anything is the cost of generating cache.
So hit rates and duration distributions are the two things for cache meshes, are the two pieces that we want to quantify the benefit of the caching. And currently there's no pushback. There's no disincentive to cache things. So our developers over the years have had every reason to try using cache and no reason not to. So
and cache lives 2 weeks if like and hypothetically would live 2 weeks while like we know now from things that we've seen that it can live maximum a day and nobody has shouted at us. So
yes.
So I guess, I mean, medium term, it definitely seems like looking at Memcache versus Redis cluster is useful. But immediate next steps, like now that Bob is back, do we want to make him do all the work that we didn't do? Is that kind of the plan?
I'm still up for that, because I think we should put out the fire.
How confident are we that the repository cache is worth moving?
I looked into that. I don't remember the numbers I said last time.
It's like
we had this
10 to
conversation.
12%, I think is what you said, of like total amount.
This is looking at the size for the keys that we that we'll be migrating. So we don't have a sense of how much. So we know that we hit saturation on a daily basis for weekdays. We don't know how, if the ceiling was infinitely high, we don't know how high usage would go. So we don't know how much demand there is beyond that saturation point. So reducing the demand by 10% may or may not be enough. We knew that the TTL reductions will further reduce
the total of not just this project, but the total was
20, wasn't it?
20, between 20 and 30%, together with the stuff that we're asking people in product to do.
Yeah. So so I wanted to since the four of us are here, I wanted to ask a naive question again. Why don't we, at least for the short term, increase max memory, raise the ceiling?
Pretty sure I asked that question before. Still think it's a good question.
Yeah,
The answer
how much headroom do we have?
Right, exactly. So we need to have at least, for safety purposes, we need to have at least double the memory that, so max memory times 2 at the host level. And I think we've got that. We don't, strictly speaking, need quite that much, but I wouldn't be comfortable running in production if we weren't pretty close to that ratio.
But what's the current ratio?
Checking. Talk amongst yourselves. Almost. I'm waiting on SSH. All right. So yeah, so the host has just shy of 120 and Redis has 60. So we're at that 2-to-1 ratio right now.
So that's your answer for not increasing max
I
memory.
Yeah, I guess so. Okay, so if
Can we increase the box?
We can. I can also be more flexible. So okay, so I think you all know this, but just to make sure we're on the same page, the reason for that being an absolute safe, like if we have double the memory, then we're absolutely safe, is that whenever we have to make an RDB file, which on Redis cache is whenever we need to reinitialize a failed replica, it needs enough memory to so the main Redis server process will fork itself to have a point-in-time snapshot of its memory image, so it can generate an RDB file and then stream that over a TCP socket to its peer that needs to be reinitialized.
It first writes it to disk, right?
That's correct. In our current configuration, it writes it to disk. So this is local, so it's not network bound. Technically, it's still network bound because disk IO is network IO in this platform. So scratch what I said. So yes, it writes the result to disk.
So it first goes to the page cache as dirty pages, but then you're also doing copy on write, and pessimistically, you're copy on writing the entire memory, the entire set. 60
gigabytes, exactly.
Yeah,
and that's that copy on write. The pessimistic outcome of the copy on write being the complete 60 gigabyte data set is why I'm out of paranoia very comfortable with double, and less comfortable the less of that doubling that we have. Practically speaking, though, we've got the whole reason. Part of the reason we're doing this is that we've got several instances recently where we had to do that, and we don't get anywhere close to spending, to copy on writing every page of memory, because the process, the forked process, doesn't take that long that every page has a key mutation on the Redis server side. So if we said 50%. Max mem time, times 150%, that would be, I think that would probably still be reasonably safe. And yeah, I think I need to look at the machine type specs again, but I think we can spec out a bigger machine in terms of memory. I need to check that.
But that also requires a failover, right?
It does, yes.
Well, we know failovers can work because that we had 5 in a row or something.
Yes, yeah, true. So
and will things be fundamentally different if we have more memory, because the application isn't changing much,
right?
And the users aren't changing,
right? So the idea is,
will we just fill up the new memory and then we have the same eviction rate and the same trouble again?
I think we'll have, like, the peaks you see every time. I think we'll have spread them more apart.
Yes, at the very least, we'll have that. And if we don't actually reach the saturation point, in other words, if the
is that because the target during eviction is a percentage of max memory, so it evicts for longer until it starts again? Or why would the peaks be further apart?
Yeah. Okay. So the rationale here is so there's two independent mechanisms. One of them is expiring key, basically garbage collecting keys that have already expired, and that's not the mechanism that we're talking about for evictions. The eviction mechanism is when we reach maximum memory, when we exceed max memory by, say, 32 kilobytes.
TTL is not a factor,
right? Exactly. The eviction mechanism will opportunistically kick out keys that have expired, but that's not its main goal. So yes. So
the TTLs are just too long. So they don't do anything. Like if we didn't have a TTL, the system would probably behave the same.
Well,
or not.
I'm hoping
we do
not.
have
Like
we do have things that are lower TTL than the 2 weeks default. Like actually most things as in memory wise have different TTL specified.
Can we doesn't Redis keep a counter when it's evicting something because of TTL instead of because of memory?
I think we do have an estimated number of expired keys that we can view.
Yeah.
Just to answer a
Go
brief
ahead.
question, there is actually a larger machine type. It's twice as big. So your options are C2 standard 30, which is what we're using now, which has 120 gigs of memory, and then C2 standard 60, which has 240 gigs of memory. So we can only go from big to really big.
What about
or custom
high
size.
memory
Or custom size.
instances? We don't have to be on a C2.
Or
Also, we
custom
have-
sizes or high memory.
Right.
At
So
that point, you can literally do anything.
Yeah. So we do want C2 as the machine family, because that gives us the effectively the highest instructions per second, or the instructions per cycle, which is, since Redis is single threaded, that's valuable for Redis throughput. The specs for I forget, the M1 and M2 class machines had weaker CPUs but more memory, and so they're less desirable for this.
Okay, we don't want them for performance reasons.
Right.
I guess my devil's advocate, or my pessimistic concern here, is that we throw more memory at it. The whole thing fills up because everybody's TTLs are too long. And then Redis will go into exactly the same memory eviction behavior, and we're no better off.
Yes, exactly. So that's definitely
not even with more time between the peaks, because how much does it evict? Does it evict until it's 1 gigabyte below the limit?
No,
No.
That's a fantastic question, Jakob. And I wanted to circle back to that. So, what dictates the time between the peaks is how much memory, how much below max memory we get after the end of this 3-phase eviction cycle. The super counterintuitive thing is, so the 3 phases are the happy phase. 1 is the happy time when our memory usage is below max memory, and that lasts for 10 to 15 minutes depending on time of day. The second phase lasts for about we'll say about 8 seconds or so, 6 to 8 seconds, and that's when evictions are actively happening, and each round of eviction. So this is, we get an incoming command, and Redis and it exceeds the max memory by, say, 12 kilobytes, 16 kilobytes, something like that. Redis will evict just barely enough to just barely get below as soon as it's back below max memory. So it's not trying to overshoot that mark. The reason that at the after the end of phase 3 we are way below, like hundreds of gigabytes below.
Well, there is a phase 3.
Yeah, phase 3 is so during phase 2 we're doing evictions to get just barely below max memory. The thing is, the arrival rate of new requests far exceeds
what happens
norm.
during phase 2? So phase 2 does only last 8 seconds.
Yeah. So phase 2 is when we're actively doing evictions. Phase 2 ends when we stop doing evictions. Yeah, exactly.
And what's phase 3 then?
So let me finish phase 2 though, because phase 3 will be obvious at that point. So phase 2 is, during phase 1, we have a normal throughput of, say, 20, 30, 40, 50,000 requests per second that Redis is able to handle. During phase 2, when we're actively doing evictions, that throughput drops to like 5K. So we have, so we have a
order of magnitude less
difference, between the arrival rate and the completion rate for incoming requests. So those requests continue to arrive because the clients are still active, right? So we have the memory that's used by those arriving requests count against the max memory budget. So just having that arrival rate be much higher than the response rate means that we're eating more memory and having to do more evictions just to make space for the newly arrived requests. That's what's going on in phase 2. So phase 2 is kicking out keys to make room for the client request buffers. Once we have enough clients stalled, that's the end of phase 2. When we have enough clients stalled that the arrival rate has fallen below the response rate, at that point, we stop having to do evictions because we continue to have just barely enough memory. We, at that point, and because we're not doing evictions anymore, we go back to our normal response rate. We burn down the backlog quickly, and then all of that memory, that hundreds of megabytes of memory that had been spent for those buffers, now gets freed, and that's why we've
Okay, so the
Yeah.
drop is proportional to the number of clients, so
Old
the
clients.
number of requests.
Yes.
So it depends on the users and the traffic.
Yes.
Yeah.
Exactly.
So that is effectively an absolute number. It's not relative to max memory.
I think so. Yes, and this is getting back to your original question of how long do we have between those eviction bursts. It's directly proportional to how much memory got freed as part of that cycle. So it's also proportional to how many clients had to be stalled.
Right, but those are all things that don't change if we get a bigger instance. So this to me doesn't sound like the peaks would be even spread further apart. So we would just be in the same situation we are now, sitting on top of 60 gigs instead of 30 gigs.
My idea of like, I don't think it would matter much, but it will matter because, I hope at least, because we would maybe have some keys that do hit TTL more often when we have that initial, like,
if we had an infinite amount of memory, then the TTLs would dominate the memory reclaim, and that's what we want to move towards.
Yes. So when we increase max memory, we move it closer to infinite, slightly.
Yes.
I suspect though that if we have most of our keys that are gotten rid of within a day, which is what Bob's analysis said before, that we don't have enough machines to make max memory big enough that this would impact.
No, I think we would need like.
I mean, I guess if we go and ask Google, we could get one, but there's going to be an upper limit to what we want to do as far as management of this goes.
Yeah.
One of the issues as part of this is lowering the TTLs for all of the keys that we're going to move, just so we don't need to store them for another week in the old instance, which could mean that we can't fall back safely because that thing would have stale cache. So at that point, we would also notice what impact the TTL has. Currently, it's set to 1 day, if I remember correctly, but don't quote me on that. So then I think we would reduce it to 8 hours during the migration.
Yeah, that makes sense. Okay, this is fantastic. This is what I wanted to talk through, and I figured it'd be easier to do as a group.
So the conclusion is
bigger instance, yay or nay?
I thought nay.
Yeah, I think I'm also nay. I mean, I know we landed. Oh yes, definitely left. Okay. Yeah, because it was the straightforward thing to, it's the smallest, simplest thing we could do. I wanted to kind of revisit why we weren't pursuing that option, and I knew we talked about it a few times before, and I figured that rather than just go ahead.
The reason we're not doing because like that's the reason we're not doing the simple thing of getting bigger machines. The reason we're not doing something longer term like Redis cluster was the initial idea, or memcached, is because we need the solution now and not in a month.
Yes.
And we're hoping this offers relief.
Yes.
Yeah. So the problem is too many things going into the cache. The rate of things being stored is larger than what Redis can effectively evict.
Yes. And the reason we have these terrible response time spikes is that our nominal CPU usage on Redis doesn't leave enough headroom to accommodate the frequency with which we have to do evictions. So if we had an instance that just had too large a memory footprint, but used less CPU time, we wouldn't have this effect. We would instead kind of hover at that max memory with evictions, running frequently in the background. But because the CPU used during evictions plus the CPU used for handling requests is greater than 1 core, we end up starving requests, and that's what drives.
They're never in the background to begin with, are they?
Right. Yeah, this is all foreground activity.
Like with modern eviction strategy, they get amortized across multiple requests, but they still happen on the main event loop.
That's right.
Yeah. So the moment you have Redis cluster, you have multiple event loops,
That's right.
and you can, well, I guess Redis can evict faster because it has one event loop. It has n event loops that can evict stuff.
Yes. Yes. Exactly.
Yeah. And where something like Memcached is smarter, from what I understand, is that it can do evictions in larger batches, because it uses custom allocator to manage memory, so you can evict stuff faster. But even there, people run it. The standard setup is distributed, so you're using the same
Yes.
strategy.
Yes.
Yeah.
Yeah, I was
And you
going to say
made
that
this.
that was the main appeal for Memcached is that it's natively distributed, whereas Redis is the vanilla
Yeah.
Redis is not.
So for me, the main appeal is what I was looking at how eviction works, and I saw that Memcached actually does more sophisticated eviction than Redis. So there was this other interesting point that I heard both from you, Stephanie, and from Matt, where we're saying we don't know what people are putting into the cache, and there is no incentive for people not to do it because there's two sides of the problem. We can't evict fast enough, or too much stuff goes into the cache. And how can we attack the other half of the problem?
Right. Yes. So we talked. So there have been a few kind of Zoom recordings about this, and not a lot of writing about it. So just to recap, I don't. I'm sure that other folks have also been kind of thinking about this. I first started thinking about this several weeks ago in the context of thinking, okay, so currently we knew that we needed to reduce TTL to get that was our first cut of kicking things out of Redis cache, but realized quickly that we really don't have any good way to identify which cache entries are the most valuable ones, the ones that say we reduce TTL to something absurdly small, like 5 seconds. That's obviously going to hurt the application, but it's going to hurt some parts of the application more. Say one key in the cache is saving us say 20 milliseconds of query time in the primary DB, which is a more precious resource than 20 milliseconds, and the same amount of time spent on a replica or making a remote service call that perhaps can handle the volume versus one that can't. So we don't have a good idea of which of these keys is saving when it has a cache hit versus a cache miss. Which cache misses are the most expensive ones? I guess that's really the framing that I think is most concise. We don't know what the cost of a cache miss is for each of these key types, and expense can be framed in a few different ways.
We can't know because it is completely dependent on application logic.
Exactly.
And we're working at the level of infrastructure, so we have no way of knowing what happens outside Redis.
Absolutely agree, and that's exactly why we were talking about having the application code that's adding these cache keys instruments cache misses to quantify whatever aspect we're going to treat as being the cost, whether it's duration to complete a cache miss, or perhaps quantifying it as it costs us, making this up, it costs us this much memory on some other crucial non-scalable system to compute whatever value we're storing in the cache. I think most of the time it's going to be response time.
Just as a note, I think that Rachel at one point was writing up an epic or an issue or a something around this. I don't know what actually happened.
To attribute it to certain features, what features are using most inside the cache. There's also a discussion ongoing with product which would instrument. Was a merge request I was reviewing where this came up as well, and we were talking about adding instrumentation to the generation part. We don't know what resource we're actually in front. We don't know if it's the database or like when we put it there. And I was talking about using the active support notification thing that we also use for the timings in the logs, to use that for rails.cache, and then we could measure how long a generation takes.
So there are some challenges with it, and you may be getting
Key
there, Bob.
cardinality.
Yes,
Yeah.
exactly. So
So
we
we
don't want
can't
to
do it per
Prometheus.
key, but we want to have it per cache. Like every time somebody does rails.cache.fetch.
The risk with
we
this
want a
sort of
smart-
thing is that you end up needing another Redis to store all these metrics, and then you're blowing that up because you're throwing all these metrics at it.
Yes.
Well, yeah. So like, yeah. Okay. So in the background, we've also been having some. I mean, I think everyone here knows this, but Prometheus is kind of hurting.
Yeah.
And I'm really
So-
worried about introducing more high cardinality.
So right now we're not doing that,
Yes.
and we're adding them to the things that we care about, which is the largest ones that we've identified on the cache.
Yes. I guess just for completeness, I want to mention also that having so targeting the keys that we most care about to get metrics forward is definitely a super useful strategy. And another perhaps complementary strategy is to add them to the log events, the per request log events, because we can do short-term analysis in Kibana to look at those distributions. Of course, we still have the problem of trying to classify, the type of key that we're storing, because we can't really do, a regex match on log events in Kibana.
I wonder if
Kind of
there's a way.
can, but
Cheaply. Oh, Stephanie, are you gonna
I mean,
whip out some magic here?
I can do a lot of crazy shit in Kibana. So if you need that, that's the thing I can do.
All right.
I wonder if we already log how much data everybody writes into Redis.
And we log how long it takes.
Yeah.
But we don't.
but
But we have multiple cache hits or cache lookups per HTTP request, and I'm not sure how we deal with that without
Well,
generating.
I'm not thinking about the reads. I'm thinking about the writes, because the fundamental problems are the number of writes, or the write volume, and the delete throughput. Right, the volume of things we are writing into Redis cache is larger than what Redis can delete. Do we have enough information to say to a stage group, you are writing a lot of data into Redis, go make it less?
I think we have that in the logs. I would need to double check, but I think we have a write bytes there. Redis write bytes, and we have a feature category there. So
one thing we don't have is writes versus rewrites. Like, rewriting a key doesn't necessarily consume additional memory. In fact, it might free memory.
yes,
although
and we also
so
we don't know that. We also don't know, because if we run that analysis now, it's either source code or somebody that builds a part of CI, because traffic like that. Yeah.
Sure, but if we want to, I'm not sure if we, people in this call, can really get a grip on the right side, the right side of the problem. And if we can somehow help isolate, or I don't know, pinpoint to some extent where that is coming from, then yes, we can. Maybe it's not fair if it's source code again, but if source code is making Redis cache fall over, why shouldn't they help?
I guess I was thinking of this as we would come up with a framing, a rubric that they could use, and then they would implement that rubric. In the sense that if we just say, hey, go figure it out, the simplest thing for them to do is add more metrics, and that will implicitly be scraped by Prometheus and blow up Prometheus. So
sure, okay. If we say to a stage group, go fix this, then maybe we need to then help them, and it comes back to being our problem.
Exactly.
But,
so I want to help them curate how they do it, I guess.
Sure, but
and we've started doing that in the epic that Stephanie created 2 weeks ago, capturing some issues. So like there
and they've actually been adding to that epic too, at least.
I
think
see.
Yeah, so people are definitely looking at it from that point of view.
I actually got pinged by somebody who wants to improve the metrics on the logs, and they saw that I contributed to the metrics code, so I have to look at that anyway. Something about
Tag,
pipeline
you're
requests.
But you want to, like, it's a very nice idea to like have a less ad hoc kind of way of doing this.
Well, I'm
Because
just
now we
wondering.
looked into it, like I used the tool that you built to do another weighted scan, and then I weighted by different things. And that's how we came up with the keys, not with the total.
Right,
Yeah.
but I wonder, is the bigger problem who owns all the data in memory, or the who writes new data to memory?
Yeah, so I'm just thinking out loud here. So so if we know that some of the cache keys get rewritten frequently, and some of them
What do you mean
get
by
written
rewritten?
once. Oh, sorry, I mean like someone you know,
Set on the same key.
exactly. So set foo to 1, set foo to 2, set foo to 20. Those aren't consuming additional memory, but they would still count as writes to Redis. So we want to the ideal value would be to distinguish between adding new keys versus overriding existing keys, and even beyond that, if taking it beyond like an integer, if we wrote the string, you know, if we wrote a 10-character string initially and then we increase that to a 1,000-character string, that's going to be reallocated in a larger slot. So it would consume more memory. So even if we had a way to differentiate between writes versus rewrites.
Do you know how we
catch that
implemented the current
case.
metrics? We look at the wire format of
Yeah.
the request, and we count the size of the request, the
Yeah,
bytes, the wire format.
that's what I figured.
That's what we're logging.
Yeah.
So that is very crude. And if we want to
Yes.
recognize rewrites, and we need to do way deeper semantic parsing of what goes in and out.
I don't even know if it's achievable in a reasonable
We would need to
amount
know
of
what
memory.
exists and so on.
Exactly.
Yeah.
Yeah,
At least
because
not
not
there.
a write's going to correspond to a lookup to begin with. So it's not even like we could, I mean, sometimes they're going to be blind writes, right? I mean, I assume that that's the case. Yeah, so that may not even be that may not be an achievable goal. So I guess kind of talking about rolling it back from what the idea would be to something that's more practical. I guess I don't have an idea of a middle ground. I mean, what we're capturing now of just, you know, bytes on the wire is definitely the easiest thing to do.
I felt really silly coming up with it, but it was better than nothing.
It's better than nothing. Yeah, absolutely. So apart from that, so I'm just kind of reviewing. So we've done a snapshot analysis where we examine the contents of an RDB file or a non-snapshotted scan or something like that.
I'm just not sure that is. I've been thinking about the same problem from the perspective of object storage, because that's what my team is actually or was looking at, or I don't know what we're doing there, but we sort of have the same questions coming up there.
Yeah,
It's also a key value store,
yes.
but yeah, Rachel was asking for ways to get more metrics out of that, and I had to push back a little and say, you know what, it's going to be very hard to categorize what each key is, who owns it, and how big it is in a sustainable way. And it's much easier to look at the delta per request, like how much are you writing or reading from the store. But the funny thing here is,
same.
well, I haven't implemented anything yet, but I'm probably going to have to. It's going to be even worse. But the funny thing here is that it's actually appropriate, I think, to look at the delta and not at the. I don't know what the word is, but there's the how much. There's the size of the stored set and who owns what stored data, and there's how much of you're reading it back or writing into it. What are the words for that? Is there a
throughput? No.
I mean, you're talking about the stored size versus the change in size.
Yeah,
perhaps?
so the amount of change.
Yeah.
Yeah, and the amount of change is the driving factor for the evictions.
Yes.
Because the amount of change writes new keys. Also, Matt, you were saying that evicting an old key, if you override a key, does it get evicted? Does it get freed immediately?
So it'll do an in-place overwrite. So the so as I recall, so Redis uses kind of a TC cache like caching mechanism, if I recall correctly. So, sorry, I guess what I'm working up to is the allocator will work in, I think. I've been looking at several different allocation mechanisms, and I may be misattributing this one to Redis, but I think the way this works is there are effectively slots that you can require. I guess what I'm getting at is if you're in an 8-byte slot and you try to write something that's 4 bytes, you're still using 8 bytes of memory. But if you try to write 9 bytes, then you'll get the next size up.
I guess what I'm trying to say is this is not about garbage collection at the malloc level, because Redis can't go to its malloc and say, free some of the stuff you're holding back.
Right.
Malloc doesn't have those knobs.
Yes.
So it's purely about keys.
It is, yeah.
So why are there,
well,
so there have to be constantly new keys.
Yes. So it's so the instrument. So I can talk about the instrumentation for so every time a new request arrives at Redis, Redis will the Redis main thread will process that request, and at the very end it will call process evictions. And process evictions normally is a no-op. The very first thing that process evictions does is say, are we over budget? And if the answer is no, which it usually is, it'll return. So to assess whether or not it's over budget, it calls a function called zmalloc alloc used, something like that, which is asking, which is essentially a wrapper around jemalloc. Hey, how much have you used? Which gets incremented at allocation time and decremented at free time. So it's a very cheap operation for jemalloc to answer that question. So I guess what I'm getting at is anything that uses, so Redis, when I say zmalloc, that's Redis's wrapper around whatever backing allocation engine it's using, which in our case is jemalloc. So whenever we call zmalloc, it will increment that counter, and whenever we call or zmalloc and zcalloc and all of its friends, and whenever we call zfree, it decrements that counter. And what was I working up to? What was the question we were trying to answer? I'm sorry, I lost track.
Rewrite.
Rewrites. Yes. Yeah. Okay. Thanks. So if we were calling zmalloc, which maps to jemalloc allocate, to say allocate a client buffer increase, then that's gonna be an allocation. If we are inserting a new key, that's likewise gonna be a zmalloc. So if we're rewriting a key, that's gonna be a zremalloc, which will
it's counting every malloc and every free. So it's a counter that goes up for every malloc. If you do a realloc, it goes down and up. And if you do a free, it goes down.
Yes.
So the actual amount of space used at the level of the allocator is irrelevant for the eviction behavior. It doesn't trigger evictions. And
that's correct. It doesn't trigger evictions, but that's used as the determinant for whether or not evictions are needed, and also for choosing the goal. Like if we've exceeded the max memory threshold, it will compute how many bytes we've exceeded it by, and that's the target. So it'll iterate through keys until it's.
But this is all based on memory that has been requested via malloc and free.
Correct. Yes.
It's not based. So if you rewrite a key, you free the old key and you malloc the new one. So that is a net. If the size stays the same, that is a net. It doesn't make a net change.
Yeah, effectively, it doesn't make a net change. Yeah.
So if there are, if we think of, say, a repository branch cache. So a repository is a list of branches or branch names, and those are stored in Redis.
Okay.
And if the repository gets a push, then we evict that and we recreate that thing.
Okay.
But it will be the same size, roughly.
Yeah.
And it will not make a big change towards
Yes.
towards evictions, right?
Yes, agreed.
There are a lot of big things in the cache that get updated, but that don't really change their size drastically.
Exactly. Like counters, for example, would behave that way.
Yeah, counters too. Yeah. Although I guess a lot of the counters are in the rate limiting thing, but
oh sure,
yeah. So do we need to blame? But there are different strategies for key naming. One of them is to have sort of a static key for the project and say project 1, 2, 3, and this is the list of branches, which is really painful if you need to evict a lot of them.
Yes.
But you can also have keys with counters in them, and a basically kind of symlinking mechanism where you can break the symlink and a whole bunch of keys become unreachable, but you don't actively delete them from Redis. The application just stops looking at them.
Okay.
Do we know if, do we have both patterns? Could it be that some feature is creating new keys all the time, and that is driving
we have a lot of
the
those
workloads?
A lot of things that use, like, again, the view caching is just when the updated add or whatever changes of like the cache key of an active record model changes, then we just...
What is the cache key of an active record model?
It's a thing that it's like every active record model has a method cache key, and that builds a cache key based off the ID, the class, the updated add, that kind of stuff. So
okay.
So then
Things
you have
like
rails.cache. Yes. So then you have rails.cache.fetch model.cache key, and with the block, and then
yeah. Is that an ingredient for how the repository cache works? Does repository cache use the cache key attribute?
In some places, not everywhere. Most of it, there's a lot of it that is actively managed. The branches cache and so on, that uses a lot of memory, and the
but they have a cache key that doesn't change over time.
No.
The branches cache that stays the same.
Yes,
and
for
its
example,
size also won't change a lot.
But there's also file caches there that I think would...
Yeah, they have the blob ID in them, so if they get updated...
Yes.
So maybe they even have to commit... If they have the commit ID in them too, then that is stupid, because then we're creating garbage.
I think that's
that's what we're doing.
Yes, I wouldn't... Don't quote me on that just yet.
Well, it's not necessarily stupid, because you're saving a Git lookup, so we're doing that. Yeah. Okay, so
lots of this stuff also stems from when we were still on NFS. That was sometimes slow. Like some things, GitLab can answer faster than Redis. I've seen the repository.exists call and so on is faster when it's uncached.
So maybe a line of investigation that would be interesting would be to see who owns cache keys that change a lot, where that basically rely on LRU for garbage collection. Because things with fixed keys, they just rewrite their keys, and that is fine, because that's not going to make a big change for our memory consumption. But anything that is like uses the active record cache key mechanism is relying on Redis for garbage collection and is therefore part of the problem. But I suppose it doesn't really help. Does it help us to know what they are, because we cannot really change that they do that?
I don't know. That's a great question. I wonder. I guess we would need like an alternative design pattern to solve that problem. I mean, without like having a concrete example, it's hard to kind of do anything more than hand wave about it. But
yeah.
I think that goes back to what Stephanie suggested about the metrics. Like, how useful is it? Like,
Yeah.
For example, one of the things that I think I haven't dug deep enough yet, but it looks like we are caching with the blob ID and the commit ID inside is content of the README, rendered content of the README. So that's a big key, and we don't expire it actively, so we let it be evicted by our max memory policy. So that would be useful. Yeah, very useful to have.
Yeah. I just as an anecdote, not as a driver. I did an analysis over, I think, maybe a 3-minute time span, something like that. A short duration sample of capturing how effectively I talked earlier about when we do have to do evictions, Redis will calculate how much over budget the memory is and use that as the mem to free target. So I captured a distribution for that calculation, and most of the time the values that we're evicting are like the target is like tens of kilobytes. Like I think the median was something like 32 kilobytes. But there were some outliers where it was a few times when it was multiple megabytes, and I bet that's what it was, something like what Bob was just talking about, where we're caching a large value, and that happened to be what pushed us over max memory. Most of the time it's small values, but sometimes it's large values. And I think I was wrong, by the way. I think my sample was more like 3 seconds, not 3 minutes. So it was a very, very short window because it's an expensive thing to instrument.
So what you're saying is that the targets, the keys to evict targets is representative of this delta.
Yes. And it makes sense. Most of the keys that we're writing are small, so you'd expect most of the time to overshoot by small amounts.
If we are doing a lazy rewrite of a big key,
yes,
then we temporarily have 2 instances, just like with the copy on write Redis memory dump problem.
Yeah.
And then we go over.
Yeah. Thanks, Bob.
Yeah, Bob, I'm going to summarize this in the scalability meetings doc, which I should have started doing when we started this meeting, but I didn't. So
yeah, but we started out as like, let me tell you what I've done the past 2 weeks, and then
right. I guess what makes sense, and Bob, we can just talk about you in your absence, but do we keep going? I mean, it seems like we keep going with the work that we have now, with the knowledge that it is only going, like that we're applying duct tape to a situation that we don't truly understand on every level, and there's a lot of moving pieces. Is that an accurate?
I mean, as an optimist, I'm going to frame it as, we know that what we're doing is going to help. We don't know if it's going to be enough.
Right. Yes. Let's totally pick Matt's up.
Yeah. There are 2 sides to the problem. We are definitely making one side better, which is evicting faster, because we get 2 Redises to evict the same stuff.
Right.
And we don't know yet.
We don't know yet
where the biggest offenders are.
We don't know yet. No, wait. I need to do it because you see me mirrored. We don't know yet how much slower we're going to make that slope.
Right. So Matt and I will continue to get these environments built. There are a number of other pieces that unblocks. Is like the plan that Bob will jump on some of those other pieces? Is it okay?
I have yet to confirm that with Rachel, but
she's out this week, so
she
yes.
said yes. Yeah, she said this is still top priority. Yeah.
And I'm going to all of the Rails stuff and so on. I hope to start tomorrow. I haven't started yet today. I'm through 80 things that I had on my list since I came back, so I hope tomorrow. Tomorrow is the day.
Okay, and Matt goes on call tomorrow too, so
yes.
So, well, you're still here.
I'm still here. Yes, I will do all the work.
And on call is going to be quiet because I'm back. It's not, nothing's going to happen. Matt will just
That's
be
how
around.
it works. Yep.
That's beautiful. I hope so.
Cool. Yeah, I think I think we're good then for like next steps, other than there's a lot of moving pieces in this problem.
Jakob, I want to, the last topic that we were just chatting about, I want to reflect on that a little bit more. I know that one of the things that Bob was doing when he repurposed your analysis script was looking at, I'm gonna do a terrible job of remembering how this is framed. The time since last, what was it? It wasn't like a last access time. It was kind of like that. So rather than looking at time to live, we were looking at the most recently used for the keys, and finding that this was part of what was informing an assessment of whether or not a particular key pattern was write once and never use, or write once and frequently access. And that was, I think, I think that was possibly a useful tactic for identifying some of the key patterns that you were talking about, where, like, like including the commit ID in the Redis key value in the Redis key's name, where the hit rate is likely to be low most of the time. Gosh, particularly coupling that with having large stored values, I think is a fantastic, hopefully low-hanging fruit.
Well, the problem is that from application design viewpoint, it's a very nice pattern to not have to actively delete everything. And do that preferably in batches, of course, but have something like Redis do it. But
well, what if we set the TTL to be really short? So like if we set the TTL to like 10 minutes or something, as opposed to hours. Redis still has to do the garbage collection, but at least the overall storage would be. I mean, we're still delegating the GC to Redis for sure, which it I think still has to do on the main thread, but it would be done in that. How Redis will
is TTL eviction even better than what we have now? Suppose that we drop the TTLs like crazy, right? Then Redis has to do a constant amount of work evicting based on time instead of memory use.
Yes. So that's a fantastic question. I haven't quantified the difference in CPU usage for doing TTL based cleanup versus eviction cleanup. But looking at the CPU profiles while we're doing eviction bursts probably gives a clue. And I'm not looking at it right now, but just from memory, I think. From memory, I have to be careful about when I say that. From my memory, I think that it was spending at least half of its time searching for keys to evict, which presumably wouldn't be as expensive.
Yeah, and that's exactly the problem, and that's I think where Redis is on the wrong track, because if you want to do this faster, you need to have whole batches or a generational system where you say this generation now gets thrown out the door in one swoop. Instead of picking off the oldest things.
So I've spent a lot of time with the eviction code path and very little time with the TTL expiry code path. So at this point,
fundamentally, I expect it to work the same way. It needs to find stuff and it needs to call to the allocator.
I mean, I don't think it's going to be 10 times as efficient. So I agree with you. I'm hoping it'll be like maybe 2 times as efficient, but that's
the question is, would the TTL, if we were expiring based on TTL rather than on max memory, is that still going to cause the same issue on the clients? That's
the question. So I don't think it will for a couple. Okay, so a couple things. The expiry handling happens so every 10 milliseconds or so, I think, or is it every 100? I think it's 10 hertz. So 10 times a second, Redis will kind of do some housekeeping work. It'll reserve a little time for itself to do housekeeping. I believe that's when expiries normally get processed. So rather than having an event per request, we would have some batch work done 10 times a second. And that batch work may or may not be able to keep up with the demand if we shift the entire burden over to, if we hypothetically shifted the entire burden to be TTL-based eviction. I don't know that that would keep up with demand. It's really hard to quantify because right now our evictions are primarily kind of driven by this aberrant pattern of making room for the client buffers. So it might be okay.
Yeah, it's just not. It just feels too hunt and peck to be evicting individual keys because they look good or bad. If you want to do stuff at high volumes.
Yeah, I want to spend more time looking at the expiry code path, just to see how, where its efficiencies and inefficiencies are going to be.
Yeah,
but I haven't.
I suppose that. Yeah.
I mean, regardless, I think I still think that partitioning the data set is required.
No, that is probably going to be necessary. One, but
whether it's through
difficult
Redis cluster or some other method, I think.
The problem with partitioning is always it's going to be functional or something else. So now we're doing a functional partition, and we hope that we that it's good.
Yeah.
So I expect Redis cluster to do better because then you get a uniform, some sort of uniform distribution.
Yes. Yeah, like I mean that it wouldn't work. I think Redis cluster is, as I understand the architecture, it would work extremely poorly for Sidekick because there's a single key that's got almost everything in it.
Oh no. That is not appropriate for that. No.
Yeah, but for cache, it's spot on. I mean, we have a huge number of keys, with most of which are small. So it seems like a really good fit for this use case.
Yeah,
we just don't have a lot of operation. I mean, we don't have any operational experience with it in production. So
yeah. So there's another meta question I've been having, which is, are we crazy to have such a big Redis cache? Are we the only people using Redis cache at this scale? Redis is this scale as a cache, or is everybody else who does it already on cluster at this level?
I think probably the latter, because it's clearly CPU bound, and like, so the pattern that either they don't care about the latency spikes, or which doesn't seem plausible, or they haven't figured out why they're happening, and moved on to a different technology, or but
they're so bad that they're triggering failovers.
Yeah.
So I think we're in a pathological Redis shape right now.
I think so too. Yeah. Yeah.
And it could be that we're uniquely big, but I
mean,
I have a bias because I was here when we were tiny, so I assume that we're not big.
Yeah. Well, I think we're big now. But
we're not. I don't think we're uniquely big.
I don't think we're uniquely big, but I think we've reached the point where we need to transition to a distributed architecture, and that's what Redis cluster is built for. So I think that I think that I think we're not blazing the trail that no one else has been on, but I think we've reached a transition point where we have to, when it's not optional anymore. I mean, the only other thing we could do is buy faster CPUs, which is possible.
It's only going to work for a certain amount of time too. Like eventually that ship ends.
Absolutely. I mean, we've played that card a few times, and
The other thing that might make sense, and you mentioned this earlier, Jakob, but if we're using Redis for more than one purpose, which it sounds like we are, maybe Redis isn't the correct solution for all of those purposes, or maybe we need to separate things out even more carefully. Like you, again, play my newbie card, but you said Sidekick uses Redis too as somewhat of a job scheduling. Like, does it?
A job queue.
Right. Job queue. Okay. And then we're using it for cache.
Sidekick can only use Redis.
Okay. So Sidekick will keep using Redis. That's fine. But
well, I can give a little bit of context here.
Sure.
I think there's two. there's two things. One is that GitLab started as something you throw on a DigitalOcean box. It's a one host, one machine, one
Right.
VM type
Yep.
thing. And we're trying to inflate it and make it bigger, but that's where it comes from.
And you can
And-
see that very clearly if you
Yeah.
look at how things are built. That makes a lot of sense.
And I think if you're new, that this is something that's, well, exactly, it explains a lot of weird stuff. And I think Redis, and I'm kind of guessing here, but I think Redis has the, it sort of fits with this because it can do everything, or it can be a lot of things for you. You need a session store, just use Redis. You need a cache, just use Redis. You need a job queue, just use Redis, because at this point, the original author and maintainer has quit because he's spent enough of his life working on Redis. But for a long time, the guy just kept adding new features because he was like, you know what? Let's just give people what they ask for. We can do this. And that really fits if you're coming from a small app and you don't want to have a lot of different components, a lot of different balls in the air. Yeah, I mean, well, when I joined, we used the file system for Rails cache. It was just a single VM, GitLab.com, and it had a directory that was the cache. And we switched that to Redis at one point. So we started stuffing more stuff into it. And we're now well along to partitioning again and having multiple Redises for different things. And yeah, where my weird let's derail the whole conversation with memcached thing is coming from is just that I'm wondering, like, if we're breaking out like this, is it an opportunity to think about it? Once we isolate, well, Redis cache already doesn't have to be everything because it's just a cache. But yeah, sorry, I ramble.
No
No, I
worries.
think it's a reasonable ramble, and I think it's a good question. It's
For
just
what
hard
it's
to
worth,
answer that question when things are on fire.
For sure,
Yep.
yeah. It has, to add to that a little bit, it has been incredibly useful to us and frankly to the Redis maintainer team, that we do separate discrete use cases into discrete shards, because that's allowed us to really easily show bottlenecks associated with a particular workload and a particular use case, and that's led to, on 2 or 3 occasions, us to contribute upstream some performance improvements and be able to demonstrate the importance of it and test the efficacy of the improvement.
Yeah.
And it also means that if we need to separate, if we want to change technologies, that it makes it even easier to do so as well.
Yes, very much so.
Yeah, no, that's a very big win for functional sharding. I've just as a small side note, I've seen the same thing with Gitly, and what happened for silly historical reasons. I don't know if you know this, Stephanie, but one of the busiest repositories on GitLab.com is GitLab or GitLab, and it was such a bad noisy neighbor that at some point it got its own server. And the interesting thing about that is
File Canario 1, by the way.
It was just File Canario 1. Yeah, exactly. And the interesting thing about that is that if you look at that server with perf, or you see what's going on, then it's much easier to make sense of what's going on, because you know that all these things are running on the same repo. You know the shape of the repo, so it's a godsend for observability and figuring out behavior, which I think is sort of echoing what Matt just said about the functional split.
Yes.
Yeah.
Yeah. By the way, when you do go on call and you get paged about File Canario 1, you can be sure 95% of the time that it's going to be either GitLab or a fork of it.
Yeah.
Excellent.
Yes.
Yeah. Which I found out, I don't know if it got fixed already while I was away, but there was this issue where when somebody deletes a fork, we also disconnect it from the object pooling repository it's connected to, and that triggers an FSCK, which uses 80 gigabytes of memory. And I And we're doing all that to check the integrity of a repository that's about to be deleted. So I was,
sorry, a Git FSCK. Okay.
yeah, Git
I'm
FSCK.
with
Yeah,
you.
sorry, no, not a file system FSCK.
I was panicking at first. I was
Oh,
like,
no.
what?
We're not, we don't have reason that I know of to run file system FSCKs. No, but
that
there's
totally makes sense, and that's totally bonkers. That's
yeah,
fantastic.
it's totally
Great
bonkers, and
point.
we didn't know that would be so bad. And I was
80
trying to fix this.
gigabytes. Oh my
Well,
god.
it's something insane. If you look at File Canario 1,
Wow.
you have this RSS breakdown by process,
Yeah.
and you see insane spikes on Git FSCK.
Okay.
And it's one of those funny problems because the Git lead team tries to somehow fix it on the Git lead level, like make the FSCK go faster or do this thing. But actually, the problem is that you can also solve the problem if you don't do the FSCK in the first place.
Yeah.
But that is application code outside of Gitly.
Yeah.
But nobody understands that code because it's so tightly coupled to Gitly. It's basically a Gitly feature that is half implemented in Rails, and the Gitly team doesn't touch it a lot because it's not their repo. And anybody who's on the Rails side, and anyway, I realized, like, I helped write this thing, so I should try and get rid of this FSCK. But I haven't gotten around to it yet. But
that's a great find.
Yeah, but it was just really weird because it's specific to forks, and it happens when a fork gets deleted and GitLab or GitLab doesn't get deleted. So some problems are very specific, will only happen to a fork and not to the repo itself. Yeah, I digress. This has been a very long call.
Yeah, I was gonna say, it looks like it's starting to rain, so I'm gonna have to go rescue my dogs in a minute. Do we have anything else? I think we covered a lot of things, and we're all more on the same page.
I think so. Yeah, and we ran through some things that will or will not work, like increasing the memory probably will not work, so we don't have to go down that path. Cool. Well, yeah, I just hope I can support Bob with the application changes and not derail too many meetings. Thanks for your patience, both of you.
You're very welcome.
Absolutely fantastic. This was a really fruitful meeting.
So, I mean, I guess I can stop recording because this is just a